People sometimes ask us how to interpret the test results tab in product descriptions. How are these tests made, and what is this Xena? Well, there are simple throughput tests that are being done according to RFC 2544. To put it simply, data is being sent through the device under testing through all wired ports at the same time, and then there are different configurations and measurements that get taken. Usually this means that a huge amount of data needs to be generated, received, and checked for validity, so we need powerful and reliable testing equipment to do that. Xena Networks is simply the brand that we are currently using in our testing. Let's have a closer look at these tables. There are three kinds of results that you can come across. Ethernet test results can be found on all routers and switches that can do routing. They focus on the CPU performance, hence hardware offloading is disabled. Similarly, switching results are found on all switches and they focus on the switch chip performance. IPsec test results can only be found on devices that do hardware-accelerated encryption. These three tables attempt to display the performance of our devices in a variety of situations, as it is impossible to show you the exact numbers that you will get in your setup. The two things that have the biggest impact on performance are the type of configuration that you are using and the size of packets being transmitted. So on the left, we have a list of standard configurations that we use in all our tests. But of course, you could have a configuration that is more demanding than the ones we test for. Then at the top row, you will see three different packet sizes. 1518 bytes, which is the maximum according to Ethernet standards, and intermediary of 512 bytes, and the smallest possible size 64 bytes. Smaller packet size means more CPU overhead, so you will get better bitrate with larger packet size while lowering the packets per second count. And of course, if you do jumbo frames, you might be able to exceed the best listed bitrate results. Now let's quickly go over the configurations that we test for. The Ethernet table will have two modes tested, bridging and routing. Bridging means that the communication happens over a bridge, and to vary the difficulty, bridge filters are also applied. Routing mode means there is no bridge, but with no further configuration, fastpath can still take place, and the throughput in that situation will be similar to bridging with fastpath. The difficulty is first increased with simple queues and then IP filter rules. The switching results configuration column is a little more different. The entries that start with the words non-blocking immediately tell you that you can achieve wire speed. Then there are rows that show throughput and rows that show capacity. Capacity is the theoretical maximum speed that the switch chip can sustain for all of its ports at the same time, but it sort of double counts the port speeds. For example, a 1 gigabit port has to be able to receive and transmit data at a 1 gigabit rate, but it can do both at the same time, so the 1 gigabit port in reality has a 2 gigabit capacity. People don't care about this measurement much. They are more concerned about how fast they will be able to download things. Hence, we have the throughput entries. They are actual test results, the amount of data that you could move through the device using all ports at the same time. Typically, this number is about half of the capacity number, but with some switch chips there can be differences. Switches that support layer 3 hardware offloading might have some additional entries mentioning L3HW. Going into the future, you can expect that our most capable switches will have these type of entries. The IPsec results simply list the throughput using either 1 or 256 tunnels at the same time and varying the difficulty of encryption and hashing algorithm. AES-256-CBC being the strongest tested encryption and SHA-256 being the strongest tested hashing algorithm. The last thing I would like to mention is that there are big differences between RouterOS 6 and RouterOS 7. The latter is more advanced and adapted for future development, so it just happens to be slightly more demanding on the CPU, and comparing version 6 and version 7 results, especially on lower-end CPUs, might sometimes give you the wrong impression. But it is all for a greater cause, which is a better product in your hands.